I'm Ishan Chattopadhyay, and we have Noble
I'm
here.
Noble. Both of us are committers and PMC members of Lucene and Solar project.
And we work for Full Story. The primary reason why we were interested in dynamic plugin loading at Full Story was that since we have a huge solar cluster there, we want to be as quick and fast with their deployments as possible.
We have a lot of components that we write. So we have custom components, and we have to rewrite new components like probably every month or so. So we need to deploy these new components without downtime. So today it takes like 3-4 hours to deploy Solar. Again, that means we sometimes lose shards and replicas while doing that.
And there's a very strong search team, analytics team, data science team back at Full Story, which you might want to have a look at because they are hiring. So the agenda of this talk here is that we'll be talking about the history of Solrs, trying to deal with the issue of plugin management, plugin reloading, plugin hot swapping, and then we'll talk about a package manager that we have built. We'll be talking about the repository structure necessary for that package manager to work. We'll talk about the other aspects like a new blob store that's coming up and the internals of the package manager. We'll then touch upon a safe mode of Solr and a Solr Lite version, and we'll touch upon that when we get there, and the future and references.
Yeah, so Solr has been a system that is built of plugins right from the beginning. So Solr config XML can be seen as like a plugin configuration. But we always recommended that a user put the jars in the file system, then restart Solr. That has been the story right from the beginning. And this is still the most prominent, popular way of deploying plugins in Solr. And in the interim, we actually introduced something like, okay, we can load something from the system collection. It's good because now you can actually, unlike the other one where now you have to say, if you've got a cluster of say 500 nodes, 1,000 nodes, sending these jars everywhere, you could actually send this to a system collection and just load from there. The problem is that they all result in core reloads, means you lost all your caches and everything, and all the requests in flight, they can actually fail. Some of them can fail while the core reload is happening. So it's pretty bad. And these components, because they rely on the system collection, which means that the system collection has to be up and running when the plugin is actually loaded. So because of that, we actually came up with a compromise like, okay, these components which are using the system collection to load plugins, they are lazily loaded. That means the first request actually pays the price of downloading the jar and loading the class loader and everything. That means the first request can have a huge cost in terms of latency, which is pretty bad. So the main problem is that you can't even load components which need to be there when Solr starts. So that's pretty bad. So we had to think of a new solution which actually can work with, which can have the best of both worlds. Basically, we wanted to have the flexibility of everything that the file system jars offer. At the same time, we wanted to have an easy deployment path where you can actually run a command and deploy our jars to, or the packages to all the nodes in like one single click without going to every node.
So just a quick shout out to Jan Hoydal, who presented something a couple of years ago. And functionally, we are trying to do something that he attempted to do in a POC. The internals are quite a bit different, and we'll probably talk about that. So one of the features that this plugin loading system is where the user would be interacting with it is the package manager. And if you were to just use it, you would probably just need to go through some of these that we are going to talk about and not care about the internals. And these concepts are essentially, first you'll have to add a repository. And a repository is a is a location, it's a web service or a file folder or a GitHub repository, somewhere from where you can load the jars from. Each of them have a manifest. So first you add a repository and register to Solr. Then you can list the packages that are already installed, list the packages that are available. You can search packages by their name. You can install particular versions of the packages. You can deploy packages, especially things like maybe a query parser or an update request handler, update request processor. Stuff like those can be deployed on a per collection basis. And you can as well update the packages as you keep going along.
In the future, what we envisage is like, people will have their plugins or packages published in public repositories, like Maven is published, or the NPM is published. So we will have Solr's packages published in public repositories, and we will be users will be using them directly from the CLI instead of building their own packages.
So briefly touching upon the repository structure, and we'll go into more details, and we'll probably try to squeeze in a demo if that's possible, if time permits. There needs to be a manifest file, which is the JSON file containing the metadata of all the packages. So in this case, in this example, there's a jar file, and the metadata would be what version that jar corresponds to, what dependencies does it have, what date, and how to set it up when you hit an install. And there's a public key using which they'll be signing, and we'll touch upon that later. This is an example of a manifest file where you have all the dependencies and all the metadata associated with a particular package. So now we talk about the blob store, the one that
to have a jar loading mechanism, first of all, what we need is we need to ensure that these jars are available in every single node in the cluster. Okay, so we had a blob store that in the past, but it cannot be used for reasons that we just discussed. So we had to again reinvent the wheel. So we built one, and so this new blob store is a fully replicated mains available in each node. It's persistent, that is, it is stored in the disk, and it is a P2P file store. So what it means is every jar, so for this system it is a blob, every blob is available from a peer. Basically, if even a single node in the cluster has this blob, that means the other nodes can reach out to that and download it. So this means that if you manage to have it somewhere in the cluster, you can get it.
This is a feature that has already landed in master. I think it's also...
No,
The blob store is already there in master. And there are other pieces which are already in some branches, soon to be merged.
So in the blob store doesn't see anything as a jar or anything. For it, it's just a bunch of bytes. And these blobs are identified with their SHA-256 hash. And across the cluster, that's how it is accessed. And there are simple commands to manage this one. So basically, you can just upload a blob by just posting your jar file to /API/cluster/blob. That means this command will just distribute it across the cluster in each node in no time, actually. So what it does is it actually asks other nodes to get it from other nodes. Okay, so you can actually scale it to like a very large number of nodes pretty easily. So because it's peer-to-peer, it doesn't, you don't have to download from one node and overwhelm this particular node. You can list the list of jars available or blobs available using a list command, or you can download a blob with this API. So we don't have a V1 API; it's all V2 APIs. So okay, so this is the meat of the system, and we can just go a bit deep into this one. So when you say that there's a package is you can have a number of packages, as you can see here, and you can have components or the plugins which can depend on one of these packages. So if you look at any of your component, like say a search handler or sorry, a request handler or a search component or whatever it is. So you can just say that a plugin can have an extra attribute which says package is equal to the package name. So when this magic attribute is present, what the system does is the system actually checks if there is a package already loaded with the name, package name, and if it is not there, it will look in the local file system and try to load this package and its class loader. If it is not present in the file system, it will try to download the package from an existing node in the cluster and load the package. So it will ensure that the first time it sees that package equal to package name in that one node, it will just try to load it somehow. So once it is available, so you can have like n number of collections having n number of components depending on this one package or any package, and it can be loaded seamlessly. So the good thing is that we can even have like global plugins, like plugins which are loaded at the core container level can also be loaded from the same package because they are available at startup. Then the okay, so as I mentioned this one, the our package just should be having all the dependents that you have. So basically, you cannot have like multiple jars for a package. So everything that is not available in the Solr's class loader should be shipped in your jar. That's one constraint, but yeah, that's how it is designed. So the most important reason why we built this was the third property, that is the hot deployment. So we don't want a plugin loading or reloading to result in a core reload, cache trashing, or node restart, whatever it is, or it can happen. It can lead to like say a lot of zookeeper events and so on and so forth. So this is pretty bad. So we wanted every single component to be loaded without touching anything else. For instance, if package 1 is changed, it means all these say red ones, these components only will be reloaded. For instance, these are search components, imagine. So there are new search components created, and the existing search component will be there, and it will be that those requests will be completing with the old package, and the new request will pick up the new search component from the new package and serve the request. So the existing requests are in flight are going to be completed. They won't be disrupted. The new ones will be served with this one. And the moment you run the command, it can like in sub-second, it can actually reload the components across your cluster. So that's it. That's zero downtime and sub-second. And the next important feature of this one is the security of this one. So basically, every single jar that is loaded will have to be signed with a private key, and these keys are available. You just keep the keys in ZK, and no jar can be loaded without signing. So that is the security story of this one. Okay. So these are the REST APIs. So basically, when Ishan showed the command line interfaces, so these are the REST interfaces which the command line internally use to actually make this thing work. So you have simple APIs, the CRUD APIs for adding, updating, deleting, or listing a package. So this can be directly used, and you can deploy your components using this one directly if you want to. If you have a separate system that manages your cluster, you don't want to rely on the CLI, you can do that.
In the Linux parlance, if you are familiar with deb files and the apt packages, aptitude packages, this will be more like how do you install a deb file, and the package manager is more like the apt.
Okay. So the typical workflow is like, you build your, so basically the development process, and you build a jar, then sign the jar. Then if you have a repository, you just publish your manifest and the jar file to the repository, then you install it and deploy it to each collection if you want to. So this cycle repeats, and this is normally basically these are the minimal number of steps that you can use to deploy your plugins in a cluster. The most important aspect of this one was like the security of how, because we are publishing code that can be executed. That means it can be attacked pretty easily. So as earlier, we actually ensured that, okay, you need to start your cluster with this property. That means that nobody is inadvertently enabling this feature without thinking of the security implications of this one. So basically, you have to be like a bit more careful when you have this property enabled.
Essentially, if you have secured your zookeeper and you're pretty confident that the zookeeper is not a surface to be attacked upon, then you could as well turn it on in your production system.
Yeah. So the weakest link in the whole Solr's thing is how you can write to zookeeper. So that security hole has to be fixed. So again, we always recommend enabling authentication, and for stuff like say package API or the blob API, ensure that only admins can access that, at least the right APIs. Then to avoid the number of service attacks, we have limited the file size to say some sane limit. You can configure it. Then you have to sign your packages, of course, and using the keys that you uploaded, the private keys that you uploaded to Zookeeper. Then this is the most important aspect. Always keep your Zookeeper safe. Basically, don't give access to everyone to write to your Zookeeper. So basically, you can just we can actually pretty much do everything using the REST API. You don't even need Zookeeper access for most of the stuff that you do with Solr. So it's a good practice to not even give out the Zookeeper access to any of the nodes other than the Solr nodes. Okay, we'll move on. We'll go to a demo. Yeah.
So essentially, we first need to start Solr with runtime lib enabled, and I'll just keep doing that and hope it works. The next step, or it can be a parallel step, would be to set up a repository. So I'll set up a repository file. This is starting. So we have Solr started up. So we here have a repository. I'm not sure if that's very well legible, but we see that there are a couple of files here. One is a manifest file, and one is a dummy question-answer chatbot kind of a jar file. In this, the manifest file's contents are here, where the important attributes are the version, and actually the setup commands and things like that. So now that we have set this up, the way to check the existing packages that are installed in Solr would be Solr package list. And this does not return anything because it's a fresh installation of Solr. Now the idea is we have to register the manifest and the repository that we just saw. And the command for that is add repo. Here the name of the repo is full story. And here is the URL. So once that is uploaded to Zookeeper, and mind you, this is the most critical step in terms of security, because if this step were to be possible to be done using the REST APIs, then anybody could register any repository over the HTTP. So this command is actually restricted only to those who have direct access to Zookeeper.
Yeah. So this is where we limit the
This is the core of the security model.
This publishes the public key of your repository into the Zookeeper. So this one can only be done from command line or with a Zookeeper access.
Right. So now that we have a repository added, we can just go ahead and have a look at all the packages that are available. Right now, there's only this question answer 1.0 available. So we just go right ahead and install it. Seems to be working. And then when we list the packages, it seems like there is a package. So now that we have this plugin, we'd like to create a collection, maybe add a document, and try to use that plugin in this collection. So the next step here is to actually deploy this plugin. So this plugin actually contains a request handler. So we'd like to register this request handler on this collection called ABC. So that's the deploy command. And then when we try to use this, so this deploy command actually registers this request handler at something called myPath. And if we hit myPath with a query, with a natural language query maybe, and it returns with something. You notice here that there's a custom field that I have populated here called version, and version is 1.0. Keep in mind when we update, this field will change. There's something else that we can use to track the fact that this plugin has been installed, is that at myPath, we can now have something called metadata, meta equal to true, and this path has been registered by a component that has been dynamically loaded. And that is evident. Yeah. That is evident from the fact that there is a SHA here.
That's the package info.
Corresponds to the.
So that's the package info which gives details about the package. Yeah.
This is also something that has been built new. Now let's say we were to build another jar, release another version of our question answering system, and in this we can see that now there are 3 files, and the manifest now has an additional version called 1.1.0, and that's what we'll try to update to. So package update gives you the updates that this system is eligible for with the registered repositories. So it tells you that there's a version 1.1 available. Actually, 1.0 should not happen here, it's a bug. We'll look into that later sometime maybe. So now the idea is, now we know that there is a later version of question answer available, and we'd like to update it to the latest version. And we go ahead, try to do that. Seems like this has succeeded. Now we try to hit the same endpoint again, and you see that the version is 1.1. Internally, I can assure you that there was no core reload that happened. Solr did not restart, and hence this is what Noble was referring to as zero downtime deployments. Again, going to the metadata, we can see that there is now a different SHA that responds from. So this update handler, this request handler is from a different jar than this one. So that's all I had for the demo. The coolness of this would be more evident if we had more packages, and the repositories could have more third-party packages or first-party packages, and that's what we are going to now talk about.
Okay.
So coming back to the coming back to what this logically leads us to, or in fairness, what we wanted to do initially and in hindsight we ended up doing, was something called Solr Lite and Solr Safe Mode. The idea here is that Solr is very powerful, and out of the box it has features which probably not any other open source package come with. But that has its own downsides when it comes to, let's say, features which you may not want to use it, or there may be implications in terms of the memory footprint, or any vulnerabilities, or any other reason why you may not want to have such features starting up in Solr. So the idea was to have these features being, the user having the ability to enable these features or disable these features as and when they want to use it or not. that gives the user the ability to more confidently put out his solar installation to the public. The public-facing APIs would be only those that your customers are going to need. So, for example, if you're just interested in a searcher, the search functionality, faceting functionality, and maybe an update handling functionality, then you would not need something like features, which it's not a comprehensive list, and by no means is this a list that we should be starting from, but this is something that we wanted to understand if we can get rid of. So when we started with that idea, there were a couple of approaches that come to mind. One is a medium-term solution. One is a more long-term solution. A medium-term solution would be just to have parametric enabling or disabling of all of these features. The idea would be that it will be simpler to implement, but the problem is the binary would still be large enough so as to leave a big footprint. The other thing is any feature enabling or disabling would require a node restart. So if you take an example of, let's say, you want to suddenly use data import handler or HDFS or streaming expressions, you would then need to restart your Solr and have them turned on using the parameter. But then there's a long-term solution, and I'd call that long-term because it's incumbent upon us to first get the package management right, and also our move from the Ant-based builds to Gradle, which we are trying to undertake soon. It would be easier to have a more modular Solr where the core Solr would be as lean as possible, whereas everything else would be something that leverages the package managers that we talked about. So the benefit of doing something like that would be that all these non-core features can maintain a release cycle that is not aligned with Solr. So as an example, we were speaking to Joel, and Joel had streaming expressions which could be released sooner than the Solr's lifecycle.
They actually release new expressions like every week.
So if you're not updated to the latest Solr version, you would not be able to leverage some of those. But now at something like Fusion.
So actually, in reality, these streaming expressions built for 8.x can be run on 6.x. No problem. So
the idea is, as soon as the package manager is fully baked in and the Gradle, we move to a Gradle build, we could start working on this. So this is pretty much all that we had to cover. The references are here. The code is checked in. It's from a branch.
It's a public branch, so anyone can.
And it could be merged into 8.3 or 8.4.
Yeah, there is some work left, but there are some quirks on the API and all those stuff, and there are something we need to fix some small bugs or something. But we plan to commit this pretty soon to one of the release branches pretty soon, and in the short term, or medium term, basically the missing features are like so basically it has always been missing. This package is equal to package name, that attribute support. That means packages can be used to load, say, schema components, or say container level plugins like say authentication and authorization plugins or whatever. So these things are not currently supported, and it requires extra work. Then we should be able to show stuff like say the package is available and deployed in an admin page. That should be pretty trivial. Then for the Lite Solr, we need to add basically build targets which can make this this modules as separate pieces. So this is a longer term work once the new build system is available. Then
some of the cool and well-known open source plugins to Solr, things like Cupid, things like Luwak, Luke, those, although they are part of the Solr distribution, some of them could be very well integrated into this plugin management system if we had some bit more functionality like the UI plugging in, and that's something that.
So eventually what we want to see is like say the components are built and distributed by third-party component developers, because we don't want everything to be built into Solr, and third-party component builders can build and distribute their packages in public repositories. And this is the direction what we want to go. So we want Solr users to just directly use those plugins from those packages, and eventually we can just rely on companies can just rely on this system to release their packages to their clients.
So lastly, shout out to Full Story for supporting this work. And if you have any questions, we'd like to take them.
Okay, I think we have a lot of questions. Yes. Oh, quick.
Question,
Okay.
Quick comment and a question. So, the .system, you mentioned some of its downsides. You didn't list the biggest that I've come across is that it doesn't support anything in the schema.
Yes, it is.
It's a complete non-starter for. Like,
Yeah, this is something. Yeah, we need to. It can be added easily, but what I'm saying is, this is not added now, but it is easily added. You can easily add it. Yeah.
Okay, and my question is, where in this do you tie a collection or a config set to a particular plugin or plugins? I missed that. Did you say that?
So normally your Solr config.xml can have, say, a request handler or search component, right? So at that point, you can just say a package is equal to something, an extra attribute.
Okay.
So
That implies that the particular request handler or the particular
search component, whatever. Yeah.
merge policy factory, whatever,
Yes, whatever. Yeah.
has that like embedded in its
Yes.
thing there.
It will be there in the.
Look at the.
When you installed it, it actually ran the add request handler config.
Right.
Because-
And that is part of the manifest. So every package version will have a setup command. So
Yeah.
when you install this jar, how would you actually load them into a collection?
So-
is something which
No,
needs
so
to be
it
specified.
is not required. So for instance, you don't need a setup command, because if you explicitly put this package is equal to, say, my package or something into your Solr config XML, that means that this setup commands are not required. So these are required only for those components which really want to do something special when it is deployed. Okay, so maybe it's already deployed from your Solr config XML. So it is not, these commands are not a requirement. It is something you can use if you want to. Yeah.
If you want to hand edit your Solr config, then you can use something like this. But if you don't want to do any of that,
So in that case,
It can manage it.
if you have a Solr config XML with package is equal to something and some for components, in that case you will only run an update package command, which means that nothing else is required. Basically, when the package is updated, the class loader is reloaded and these components are reloaded, and you don't need to run any of these setup commands. Make sense?
Shalin,
Yeah.
Houston.
Yeah. Is there a list of plugins which are supported by this?
There are none as of now.
No, they are supported,
No, in the sense.
which can be supported.
No, what I'm saying is the repositories are not there. What I'm saying is any plugin that you have written today can be released like this.
Except for schema today.
Yes,
Right,
yes, yes.
So anything that is supported by the schema API or the config API can be registered like this,
Yes.
as well as the cluster level, like a collection handler or something.
So if in your shop you are already deploying your plugins, custom plugins as a jar along with Solr, you can just pull them out and
Something
use-
that's not supported are the metrics based packages, maybe authentication packages, plugins, or,
so the main
schema based plugins. Those
the
are
main
something
thing, the main missing piece is the schema thing.
Not the schema. So even this doesn't do the schema yet.
yeah, this is the missing piece here.
But the reason is like the main reason is that the index schema is a very gnarly it's quite hard to like refactor it to like have this custom components, but we can do that. What I'm saying is it is unlike Solr config, which was refactored to have pluggability.
Yeah.
The index schema.java has been like, I think for the last 10 years it has been not touched. Okay, so
If this catches on more, maybe
yeah,
there'll be more motivation to work towards that.
yeah. So basically it should be fixed, but now this is closer to fixing. But what I'm trying to say is, yeah, it is a bit difficult. Yeah, yeah. Go ahead.
One more question. You said to enable this, you have to enable runtime live.
Yes.
But doesn't that enable the
The old
old blob
Blob.
store based plugin management?
Yes, it does.
So the
And
idea
is
that
is that a security problem?
Yes, that is, and we really want to.
so we want to get to a situation where this completely replaces that.
Okay.
So one safe way to do that would be to deprecate the old plugin loading
Yeah.
in 8x and remove it in 9x, and in the 9x
So
line
we-
we introduce this. That would
we
be the
should-
more conservative.
We can have a separate flag.
We can have a separate flag to use this one. Actually, we can just use enable pack. We can just change it so that now we can use enable package, and eventually we'll just get rid of the other flag. Yeah.
And the last thing is it's more of a suggestion for the community. Maybe it makes sense to have like a Apache hosted repository
Absolutely.
for common plugins.
Yeah.
Because not everybody would like to be able to
Depend on third parties.
Yeah.
like be able to add any repository on GitHub. That can be another.
Yeah. No, basically you will trust the
So-
public keys of people, but as long as, say, for instance, if I trust, say, Apache and Apache's jars are
Or
hosted
if
in
we
somewhere else,
trust
it's fine.
Shalin, who has already made some releases for Apache, we might
Basically,
want to download
we are
from
only
your-
trusting your public key. It can be hosted anywhere.
I guess what I'm trying to say is
Yeah.
there probably has to be like a whitelist of repositories that can be added.
Right.
I think that would make me sleep in peace on my Solr clusters.
Sure.
So maybe like a read-only file which the Solr user only has permissions to read and not write. No, I wouldn't even put it in Zookeeper actually.
Yeah.
Yeah. So Zookeeper is currently the only place. Houston had a question, and then there's a question.
Yeah, so mine was quick. Do you all have plans on adding like versioning of like packages, like I guess version compatibility information for packages? with
It is
Solr?
already there.
Yes.
Yeah. So basically, if you go back to the this one, there's a min Solr version.
So there's a version, and there's also dependencies. We haven't done anything for this demo, but you could have one package depend on the other. So as an example, you might want to use this query handler with a particular cache implementation, something like that.
Okay. Max Solr version would also probably.
Yeah.
Yeah,
That's a
was-
good,
yeah.
good suggestion.
Yes.
There was a question at the back first.
Yeah, there is. Yeah.
Why did you decide to limit this plugin system to just single jars per plugin? Because typically, when I'm thinking about custom implementation of a component, it may depend on other jars as well.
So then we'll have to
Yeah.
create a fat jar out of that using some Maven shader or something.
So basically
it was
you-
just for the ease of
Basically, we wanted to avoid complexity of like, okay, this component relying on this jar, and this was reloaded, but this was not reloaded.
And the whole idea is
yeah.
that each package is a separate class loader. So it doesn't have those problems that one class loader.
Yeah.
Um,
So it's okay to like, you can just okay, put all your dependencies in one fat jar and it's
so
fine.
technically, it should be feasible what you are suggesting.
Yeah, but
it's
it is-
just that for the sake
Basically,
of
we just wanted to avoid unforeseen errors that can happen because of this one. Yes. Okay. Yeah.
Related to versioning, you said like those plugin can install a particular collection. But if say in a one single host there are multiple collections and each collection has a different configuration, how you handle that versioning?
This is the version of Solr, not the version of anything else.
Because there is a single JVM running
Yes. So
on the host which has a different collections.
Right.
But I install a latest version for a second collection. First version, one collection is using previous version.
no, you can't
So-
do that.
the suggestion is that if there are two versions of a particular package and different collections want to use different.
Oh, you
versions
want?
of a
Okay, that's
particular
possible.
package.
Yeah, you can do that. Basically, we can use.
It should be possible, yeah.
You can use different names for this one. For instance, you can say, I can create a package with the name package 1 and package 2. Both are essentially same jars, but same classes, but
In
they can have
production,
different
generally, it's not a recommended practice because of.
names. Okay. Timeout. Okay. Yeah. We can just discuss after this. Yeah.
We can take questions.
Thank you.
Thank you very much.
Yeah.
Thanks.